Welcome to this class. Today I am continuing the chapter Force and Motion of the subject Science and Technology of class 9, and this is part 3. In part 1 I discussed a lot about different terms related to the motion of the body. They were distance, displacement, speed, velocity, average velocity, uniform velocity, non-uniform velocity, scalar, vector, acceleration and retardation. And after the understanding of all these terms, which are very important, I told you the example also, and I present all these terms with the help of a diagram also. After this class, I told you about this equation of motion. We established 4 different equations of motion, and today in third part I am going to execute those equations. I mean to say I am going to use this equation to solve numerical problem. Today we are going to study which particular numerical problem can be solved by using which particular equation. The selection of equation is very important. Okay. For this, I want to recall something taught in previous class in part 1 and part 2. We need to recall this part and then only we will be able to solve the numerical problem. Look at this previous information. Remember this name SUVAT, or you can remember this UTSAV, Utsav or Subhat. But we are not interested with the name. Exactly, we are interested with the spelling. UTSAV or SUVAT, they are the symbol of different physical quantities. And what are these physical quantity? These are the physical quantity. S, distance traveled measured in meter, U, initial velocity meter per second, and V, final velocity measured in meter per second, A, acceleration meter per second square, and T, time taken, its unit is second. We are using SI system in this numerical problem. Okay. Now after this, we have to remember 4 different equations which we established in the previous class in part 2. What are these equations? Number 1, V equal to U plus AT. Number 2, S equal to U plus V by 2 into T. Number 3, V square equal to U square plus 2AS. And number 4, S equal to UT plus half AT square. Without this equation, we cannot solve numerical problem. One of them is always used to solve the numerical problem. Sometimes 2 of them are used to solve single numerical problem. But in the meantime, I want to introduce another physical quantity, that is acceleration due to gravity. What is it? Now let's understand about this. Let's say this is a body and it is dropped from certain height. Then suddenly it falls down in a straight line like this. At first, when it was in our hand, then its velocity will be just 0 meter per second. It is at rest. But what is found, when it is released, then at the end of 1 second, its velocity is found to be 9.8 meter per second. And at the end of second, its velocity is found 19.6 meter per second. And at the end of third second, its velocity is found 29.4 meter per second. I am not writing any number haphazardly. Actually, this is the observation of the scientist. Scientists observed the motion of the falling body in different places of the earth, and they declared that the acceleration produced on a freely falling body is 9.8 meter per second square. Look at this. Every second its velocity is increasing. 9.8 meter per second, here also 9.8 meter per second, here also 9.8 meter per second. The increment of velocity in every second is, if 9.8 meter per second, then acceleration on the body will be 9.8 meter per second square. And this is the declaration of the scientist. And in average, it is 9.8 meter per second square, because the value of g at 45-degree latitude is found to be 9.8 meter per second square, and this is taken as average value, and we are using this value to solve the numerical problem. Whenever we need to use the value of acceleration due to gravity, we will use 9.8 meter per second square because this is the standard value declared by the scientists. Now we can find this by the help of this equation also. Look at this, A equal to V minus U by T. We know about this because it was established in first class. I mean to say in part 1 I told you about this equation. Now what is V? V is final velocity. In this case we can say that this is final velocity. And what is U? U is initial velocity, in this case 0 meter per second. And how long the body takes to go from U to V? That time taken by the body is the t, and if we divide v minus u, that is the change of velocity by time t, then we will get change of velocity by time t is equal to acceleration, and this way we can calculate 29.4 meter per second minus u is 0 meter per second, t is 3 seconds. This is equal to 29.4 minus 0 is 29.4 meter per second divided by 3 seconds. If we divide 29.4 by 3, then we will get 9.8 meter per second square. Meter per second square, this second is in denominator, that's why this is meter per second square. This is the value of acceleration. What is the conclusion? When a body is dropped from certain height, every second its velocity goes on increasing. And if every second velocity goes on increasing, then acceleration produces on that body. And this value is 9.8 meter per second square. But a question is there, without the force, a body never accelerates. This is very meaningful understanding about the acceleration. If acceleration is produced on a body, you have to understand that certain constant force is acting on that body. That's why the acceleration is produced on that body. But here force is not applied. Then how this acceleration is produced? This is because of the gravity force of the earth. This acceleration is because of gravity of the earth. That's why we can say that this is acceleration due to gravity, and it is denoted by small g. Acceleration due to gravity is denoted by small g. And what is the difference between A and G? A is the acceleration produced on a body due to the applied force. Maybe the force is applied by a person, maybe the force is applied by a machine. But G is the acceleration produced on the body due to the gravity force acting on that body. This is the difference. Otherwise, basically they are same. Both of them have same unit, meter per second square. Both of them are vector quantity. They have a definite direction. Acceleration due to gravity has the direction towards the center of the earth. G is acting towards the center of the earth. That's why there is no difference between A and G, but the only one difference is one is produced due to the gravity, another is produced due to the applied force. Okay. Now after this much, now I want to go ahead with some important informations. Before solving numerical problem, we need to know some important information which comes frequently in the numerical problem. What are they? Important information before the numerical problem. In the numerical problem, sometimes we have to face some other sentences or words. Somewhere maybe a body is starting from rest. I mean to say, body starts to move from rest. At this time, we have to remember that if any object, whether this is car or bus or any body, starts from rest, then initially its velocity was 0. That's why u, initial velocity, we can write 0. Now next, when a moving body comes to rest, in numerical problem, if it is found that somewhere moving body came to rest, just for example, a bus moving with the velocity of 90 km per hour is stopped by using brake, then If it is stopped, then finally its velocity becomes 0. That's why you can use this information b equal to 0. Next, when a body is thrown vertically upward, if we throw a body vertically upward, then what can we expect? Every second its velocity goes on decreasing and decreasing and decreasing. And at maximum height, its velocity becomes 0, isn't it? And that's why the final velocity is 0. We can take v equal to 0. If you are told in numerical problem that a body is thrown vertically upward, then you can take the final velocity 0. But there is another matter also. If a body comes in air, then it is acted upon by the gravity. Gravity acts on it. And the motion produced on the body is acceleration due to gravity. And that's why instead of A, we'll take A as g, small g, acceleration due to gravity. But its direction is towards the center of the earth, but the body is moving away from the center. That's why we have to take minus g as acceleration on that body. So, if a body is thrown vertically upward, we'll take final velocity 0 and acceleration minus g means minus 9.8 meter per second square. Now, another information. When a body is dropped from certain height, what do you think? Initially it had motion? No. It was in your hand and its velocity was 0. That's why initial velocity of the body is 0 when a body is dropped. We can say that u equal to 0. And every second its velocity goes on increasing because of the gravity of the earth, and already declared that this is acceleration due to gravity and its value is 9.8 meter per second square. If a body is dropped, we can take two information ourselves. One, initial velocity 0 and acceleration is equal to g. After the understanding of all this information, now we have to remember 4 different equations which we are going to use to solve the numerical problem. The equations are v equal to u plus at, s equal to u plus v by 2 into t. I told about this, but because of this acceleration due to gravity, somewhere we have to change this equation also, or maybe somewhere it is written like this. Instead of v equal to u plus at, may be written v equal to u plus gt. What is the change? Instead of a, we are writing g. A is acceleration, g is also acceleration, but due to gravity, it means the body is falling downward. If a body is falling downward, instead of using v equal to u plus at, we can use v equal to u plus gt also, or somewhere if it is written like this, don't be confused, this is just the acceleration. Somewhere maybe v equal to u minus gt. Minus gt means if a body is thrown vertically upward, then its acceleration will be negative, minus g. That's why u minus gt may come in some of the numerical problem. Okay, s equal to u plus v by 2 into t can be written as s equal to u plus v by 2 into t. It means we are concerned with a falling body, and the distance covered by the falling body can be represented by height h instead of s. Third, v square equal to u square plus 2as, and in place of this, v square equal to u square plus 2gs can be used. Here a is changed to g, s is changed to s because of the same reason. If a body is falling downward, then acceleration can be written g also, and the height from which it is dropped can be written as h. Now fourth one, s equal to ut plus half at square can be written like this also, h equal to ut plus half gt square. What is the change? S is, instead of s we are writing h, and instead of a we are writing g. Okay, after all these understanding, what I told you, SUBAT, meaning of each of the symbol, and I told you about 4 different equations of motion, and then some important information which may come in the numerical problem. After all this, Now we are able to solve the numerical problem. Okay, let's start. A car starts to move from rest and gains the acceleration of 0.5 meter per second square. Calculate the final velocity gained by the car in 40 seconds. Looking at this information, here it is, a car starts to move from rest is told. It means initial velocity is what? 0. U is 0. And gains an acceleration of 0.5 meter per second square. It means we can write acceleration A is equal to 0.5 meter per second square. Now another 40 seconds is given, time is given here. Calculate the final velocity gained by the car in 40 seconds. That's why we can write time t equal to 40 seconds, and the question is final velocity is equal to what? Now three informations are given, u, a, t, and fourth is asked, v is asked. Now we have to group them, u, a, t, v, and we have to source an equation of motion where these four symbols are present, and we are using that equation to solve the numerical problem. Okay, among these four, which one is suitable? What we are searching? U, A, T, V. Now here U, A, T, V, it is present in first equation. Fortunately, the first equation contains U, A, T, V. Second doesn't contain U, A, T, V. U, A is missing. Third doesn't contain U, A, T is missing. U, A, T, V is missing. That's why we are using first equation to solve our numerical problem. Okay, now let's come back to numerical problem. Look at this. We have what? We have V equal to U plus AT. We decided to use this equation. Yeah. Now we are taking the value. We have to calculate V, and we are taking U0 here, and A is 0.5 and T is 40. We are not using units in the process. If you can handle these units and you can go up to the answer with the unit, then okay. Otherwise, units are not necessary in the process, but in the given we have to write unit, and at the end in the answer we have to write unit, but in the process you can ignore the units. That's why I am not showing the unit here. Okay, next step, 0.5 into 40 becomes 20 meter per second is the final velocity. We can write one sentence for our solution also. Therefore, velocity of car is 20 meter per second. Okay, very easy. We solved one numerical problem. You can say that this is easy numerical problem, that's why easily solved. Okay, tough also comes. Let's see another numerical. This is another numerical. Look at this. A car moving with the velocity of 36 km per hour. What it mean? The initial velocity is 36 km per hour and gains the velocity of 54 km per hour. What it mean? Final velocity is 54, isn't it? When it covers 100 meter distance, after covering 100 meter distance, it gained this velocity. How long it takes to gain this velocity? Now time is the question. Okay. Now first I want to write the information given. What is given? A car is moving with the velocity of 36 km per hour. Okay, initial velocity U equal to, I am writing just U only to save time. You can write initial velocity in bracket U equal to how much? It is 36 km per hour. 36 km per hour. Now this value is not useful to us. Why not useful? Because we are following SI system. That's why we are not using kilometer per hour, we are using meter per second. So I want to convert this 36 km per hour into meter per second. This is equal to 36 is if multiplied by 1000, then kilometer converts to meter. Because kilometer is bigger quantity, a bigger quantity can be converted to small quantity by multiplying it with the relation. There is a relation of 1000 between kilometer and meter. 1 kilometer equal to 1000 meter. That's why to convert kilometer into meter, I am multiplying it with 1000. Now kilometer converts to meter. Now in denominator we have nothing. It means we can write 1. And this is hour. Hour can be converted into minute by multiplying it with 60. Again, if we multiply with 60, then it comes in second. Numerator came in meter, denominator came in second. Now, we can go through the calculation like this. 6 ones are 6, 6 are 36, 6 ones are 6, 6 ones are, and the final result is 10 meter per second. This is our initial velocity. Now, looking at the question, we have to write other information also. Gains the velocity of 54 kilometer per hour. This is final velocity. That's why I'm writing final velocity V is equal to 54. Final velocity V is equal to 54 kilometer per hour. Now, kilometer has to be converted into meter. How? The same method, 54 multiplied by 1000 divided by 60 into 60 gives meter per second. This is equal to 0 0 cancel, 0 0 cancel, 6 ones are 6, 6 nines are 54, and 3 twos are 6, 3 threes are 9, 2 fives are 10, 5 threes are 15. We have 15 meter per second. This is final velocity. Now we have to write all the information when it covers 100 meter distance. Distance is also given. S is equal to 100 meter. Now what is the question? How long it takes to gain this velocity? Means how long it takes? T is equal to what? Question is time. Now looking at this information, now we don't have to go through this question. We converted the question into mathematical form here. What is given? U, B, S. And what is the question? T. U, B, S, T. We can make a group of U, B, S, T. We have 4 quantities. 3 are given. 4th one is the question. U, B, S, T. Now we have to search an equation which contains U, B, S, T, and we are using that equation to solve the numerical problem. Look at this equation. Again, I am showing the 4 equation. U, B, S is missing here. That's why we are not using this equation. U, B, S, T, here it is. That's why I am using this equation. But someone can ask me, why not 3 and 4? Because U, B, S, T is missing. One of the physical quantity given in the numerical problem is missing. That's why we cannot use this 3 to find T. And 4th one, U, B is missing. That's why 3rd and 4th can also be not used. We are using S equal to U plus B by 2 into T. Okay. Once it is declared, now we are using this way. We have S equal to U plus B by 2 into T, or the value of S is given here 100 equal to, I am not using units in the process, okay, 100 equal to U is 10, V is 15, and divided by 2 into T. If 2 is taken to left hand side, then we will get 200 equal to 10 plus 15 becomes 25 into T. Now if 25 is taken to left hand side, we will have 200 divided by 25 is equal to T. If we divide 200 by 25, then answer will be T equal to 25. 8s are 200. You can use calculator. Thus, lastly we got T. What is the value of T? 8 seconds. You can write one sentence for this numerical. This way we can write how long it takes to gain this velocity is told. That's why car gains this velocity. Car gains the final velocity 54 km per hour in 8 seconds. We can write one sentence for this also. Okay. Now let's go to another numerical problem. We are continuously using equation of motion to solve the numerical problem, and I am selecting a particular equation to solve the particular numerical problem. which equation is useful to solve which numerical problem, we have to find out this, and then we can solve the numerical problem. Okay, now let's go to another numerical. If a body is dropped from a tall tower, strikes the ground with the velocity of 40 meters per second, calculate the height of the tower. Only one information is given. Now, is it possible to find the height of the tower? It seems to be very confusing. Look at this, only 40 meters per second, only one information is given, but there are some other information hidden in this sentence. Now, we are going to find out this hidden information and we are solving this numerical problem. Now, how? First, I am writing the given information. When a body is dropped from the tower, at last it strikes the ground. It means the final velocity is 40 meters per second. Final velocity v is equal to 40 meters per second. Now, here we can say that when a body is dropped, at first its velocity is 0. Why? Because it is in our hand before the drop. So, here we can say u equal to 0. And when a body is dropped, then every second its velocity goes on increasing and it accelerates with the acceleration due to gravity. That's why acceleration a is equal to g is equal to 9.8 meter per second square. These are the hidden information. Okay. Now, what we have to calculate? Calculate the height of the tower. Height of the tower means s is the distance covered by that falling body is the height of the tower, s equal to h equal to what? This is our numerical problem. Now, look at this, v is given, u is given, a is given, now we have to find out s. Now, v, u, a, s, in which equation these physical quantity are present, v, u, a, s, we are going to select that, v, u, a, s. Out of these four, let's see first, v, u, a, s is missing, v, u, a is missing, v, u, a, s. Yes, this is our equation which we are going to use. But the fourth one, v is missing. That's why third equation we are going to use to solve this numerical problem. So, I can write we have v square equal to u square plus 2as and value of v is 40, 40 square equal to u square means 0 square plus 2 into value of a is 9.8 into s. We are going to find out, in place of s I can write h also, height of the tower. Okay, here 40 square means 4 4s are 16, 20 equal to 0 square means 0 plus 2 into 9.8, 19.6 s. Now 0 doesn't have any meaning, that's why I want to ignore this. 1600 equal to 19.6 s. Now 1600, if 19.6 is taken to left hand side, we will have here 19.6 is equal to s. Therefore, now we have to use calculator. Now calculator, I am using it. What is our value? Look at this, 1600 divided by 19.6. 1600 divided by 19.6. This is equal to 81.6326. 81.6326. 81.6326. Now look at this. After the decimal point, we are using just 2 digits. Third digit is if less than 5, then we'll ignore that. And if it is greater than 5, we'll take 1 as carry over to this second digit. That's why we can say that the height of the tower is 81.63 meter. This is our final answer. Okay, now we are going to solve another numerical problem also. Let's start another numerical problem. Today we are going to focus ourselves to solve the numerical problem. The major problem is which equation should be used to solve which particular numerical problem. That depends upon the given information, and after writing the given information and selecting the proper equation, we'll be able to solve any numerical problem. Okay, let's go to another numerical problem. A bus was moving with a constant velocity of 72 km per hour. Do you remember what is constant velocity? In part 1, I told about this. What is constant velocity? A body is said to be moving with constant velocity if it covers equal distance in equal interval of time. Here, its constant velocity is 72 km per hour. What it mean? Every hour it covers 72 km distance. That's why it is in constant velocity. Now, if it accelerates at the rate of 2 meter per second square, how long it takes to cover a distance of 300 meter? Okay, now we are writing informations and we will select the equation, which equation is suitable to solve this numerical problem, and then we'll solve the problem. Okay, the first information is constant velocity of 72 km per hour. Whether it is constant or not, this is initial velocity. That's why I'm writing initial velocity u equal to 72 km per hour, and this is equal to 72 if multiplied by 1000 and it is divided by 60 twice, then we'll get it in meter per second. You use calculator and get this result 20 meter per second. I'm going to tell you one secret matter. If velocity of a body is 18 km per hour, then it will be 5 meter per second. Just double of it, 36 km per hour, 10 meter per second. Just triple of it, 54 km per hour, 15 meter per second. In the same way, 72 km per hour, 20 meter per second, and 90 km per hour, 25 meter per second. But we cannot write directly. We have to show all these, and we have to use calculator, and then only we'll get the number. Okay. Now another information, what is given? Accelerates at the rate of 2 meter per second square. This is acceleration. A equal to 2 meter per second square. Next information, how long it takes to cover that distance? This is the question. 300 meter is distance. S equal to 300 meter. And the question is how long it takes to cover a distance of 300 meter, means how long it takes. T equal to question mark. Now looking at the question, what is seen? U, A, S are given. T is the question. Really question is T. U, A, S, T. This symbol we are going to solve in the equation. U, A, S, T. Where is it? U, A, S, T. U, A, S is missing in first. U, A is missing. U, A, S, T is missing. U, A, S, T. All these are present in this fourth equation. T is present in two places. It doesn't make any difference. We are using this fourth equation because it contains U, A, S, T. All four this physical quantity. Okay, let's use this. We have S equal to ut plus half a t square, or S is given 300 equal to u is given 20 into t we have to find out, and plus half a is given to t square. Now this 2 cancel, or this is equal to 300 equal to 20t plus t square. Now it appears as quadratic equation if 300 is taken to right hand side, and if we arrange them, then what we get, t square plus 20t minus 300 is equal to 0. Look at this, it seems to be what? Quadratic equation. So what? We can solve this. This quadratic equation, we know how to solve quadratic equation. I want to get the factor of 300 first. 300, 2 1s are 2, 2 5s are 10, 0, 2 7s are 2 5s are 3 2s are 6, 3 5s are, and 5 5s are 55. If we make a group of 2, 3 and 5, if we multiply these 3, 5 3s are 15 into 2 is 30, and if we multiply these 2, then 5 2s are 10. Now what we get? 30 minus 10 is 20. That's why I can write this way, or t square plus 30 minus 10 t, this is equal to 20t minus 300 equal to 0. Okay. Now I am continuing the same over there also. Okay, first let's see what is happening here. We can open this bracket, t square plus 30t minus 10t minus 300 equal to 0. Okay, now what we are going to do? We have to take t common from these two and 10 common from these two. I want to do here. If t is taken as common here, t plus 30 and minus 10 is if taken as common, minus 10 t minus minus plus 30 is equal to 0. And if we take common again, what? T plus 30 here, t plus 30, and in first expression t is left, in second minus 10 is left, this is equal to 0. Now we have two equations. One is here t plus 30 is equal to 0, this is equation number 1, and t minus 10 equal to 0, this is equation number 2. From equation 1, from this equation 1, t is equal to minus 30. Minus 30 seconds, is it possible? This is not possible. Time is a scalar quantity, its value is always positive. Here it is negative, that's why time never be negative. We can write this way, time never be negative. Never be negative. So we have to ignore this minus 30 seconds. Now from equation 2, t is equal to 10 seconds. This is the correct value. That's why the final answer is 10 seconds. So we can write one sentence for this. According to the question, we can say that how long it takes to cover that distance? It takes 10 seconds to cover that distance. Okay, this problem is also solved. This way we can solve the numerical problem related to the motion of the body, and there are 4 equations. Which equation is suitable for which numerical problem, that depends upon the given information of the numerical problem. I think from today you are able to select the proper equation to solve the particular numerical problem. Okay, this much for today. Thank you.